Good morning, Rohan. How are you doing?
I'm doing good, sir. How are you doing today?
Very good. So we have been doing some basic trigonometry. We learned about how do we find the primary trigonometric ratios and even convert and get the inverse of them. So can you do all that?
Yes, sir. I'm having more comfortable, feeling more comfortable in solving all this. And I can't wait to start now focusing on either word problems or starting reciprocal trigonometric ratios.
Great. Yes, those reciprocal trigonometric ratios are also called secondary trigonometric ratios. But before we go there, let's take up some application questions based on the primary trigonometric ratios. And from there, I will introduce you to the secondary, which are basically reciprocal of these primary ones. Okay. So let me share with you the lesson which I have prepared. Uh, let's see. We'll talk about tangent ratio today and see how we can use tangent ratio and then uh, solve many application questions. Can you see my screen?
Yes, sir.
Perfect. So you remember what is the tangent ratio? What is tan theta equals to?
Tan theta is opposite over adjacent.
Okay. Always we have to write with lowercase, correct?
Yes.
Let me write O for opposite over adjacent, correct? In a right angle triangle. So as you can see here, I've formed a right angle triangle. This is the opposite side, that is the adjacent, and this ratio is called tan of the angle theta, as shown in this particular figure. In short form, which you try to remember as SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is the ratio of opposite over adjacent. Now, we have many applications related to these. We'll focus about 4 or 5 of them today. So it's going to be very interesting. We'll talk about the slope or the gradient, right? You know what is slope? Slope is rise over run, correct?
Yes, sir.
So rise over run, as you can see in this particular triangle, rise is opposite side and run is adjacent side, correct?
Yes, so X by Y coordinates, right, sir?
Change in y, yes, change in y over change in x, correct? So we can call this as delta y and we can call this as delta x, correct? So when you say y equals to, let us say 2x plus 3, for example, then the slope m is 2, correct?
Yes, sir.
This slope m is change in y over change in x. So that means tan theta is equal to 2. What is the theta there? Theta is the angle which is formed with the x-axis. Do you see that? This is x-axis. That is the angle.
Yes.
So you can find from slope directly the angle. You get the idea.
Yes, sir.
That is one of the major applications. The other application is height and distance questions. So, for example, if you observe something from a point and you know the angle of elevation, the angle at which you are observing, let us say a flag on top of a building. And if you know your distance from the building, the horizontal distance, then these two ratios can relate the information. If you know the angle, you can find the height, correct?
Yes,
Because
sir.
tan theta is height over distance. Perfect. Lastly, we'll also talk about subtended angle. Now, this is very interesting case, which is not dealt in many books. But we have seen so many test questions based on this. Think about a bird flying. Do you see a bird flying there? And
Yes.
when you look at the wing span, so when you see the wingspan of a bird, you can see what is the total angle from one end to the other, correct?
Yes, sir.
That can give you the idea of width of the wingspan, right? Because if you see half of the triangle, it is again a right angle triangle, the angle being half of what you observe, theta by 2. And so this distance, half of the wingspan, could be related with the distance of the bird from the position, right? If the bird is flying high above in the sky, and if you see, well, the angle is one degrees, for example, you can estimate the height of the bird also. Because standard wingspan, we know birds, let us say some eagle is flying, we know the wingspan of this evil is about, let us say, 30 centimeters, let us say. In that case, by knowing the angle, we can find how high the bird is. Get the idea?
Yes, sir.
Fixed with tan theta, correct? So these are the applications which we will be talking about. Basically, as you know, on a circle, let us say a unit circle, any point on a circle is called point xy, correct?
Yes, sir.
So if point P is xy, then if I connect that point with the center O, the angle formed with the horizontal positive x-axis is theta, then we know tan theta is ratio of y over x, correct? So
Yes,
you
sir.
can also find tan theta in this particular way, correct? So there are so many applications which relate to tangent ratio, as you have seen right here, correct? Correct.
Yes, sir.
So what I'm doing here in this particular, let me just try to write this in a proper way, right? So can you please read the student's activity?
Explore what happens when theta increases from 0 to 90 degrees to the gradient of line OP. Let us record the changes in tan theta as theta increases from 0 degrees to 90 degrees.
What I'm trying to say here is that's a coordinate plane, right? So we have a line which could be kind of like this. So at this position, this line is making 0 degrees, correct?
Yes, sir.
Now we'll assume different positions of this line when it is kind of like this. Let us say it is 30 degrees. Or when further its slope increases to like this. So where this is like say 45 degrees. And further, let me just increase the slope to 60 degrees. Do you see that?
Yes, sir.
So as the slope increases, what is going to be the value of tan theta? That is what we are trying to measure. Is that clear to you?
Okay, yes, sir.
One way to do this is that we could have a unit circle here. So one way is to draw a unit circle. Let me just draw a circle here. You get the idea? So
Yeah.
on a unit circle, if I take up a point, so this will be the point on the x-axis, and that point is going to be what? Let's say 0, 1. Let's say this point 0, 1. Okay, so because I should say 1, 0, sorry. Let's say this is a point which is 1, 0.
1-0.
Now at 30 degrees, the point will be square root 3. We will look into the special, you remember the special triangles?
Yes, sir.
Correct? So if you look into the special triangle, in that case, this point is going to be square root 3 by 2. That is the x value. And half is going to be the y value. Take the point at 45 degrees. In that case, the point will be 1 over square root 2, 1 over square root 2. And if you take a point at 60 degrees, it will be at half square root 2.
By square 3.
Correct? So these are the points on the unit circle, right? That should have been 1.
Okay, sir.
So these are unit circle points. Now from these points which are there on the unit circle, you can find the value of tan theta by calculating the ratio y over x, correct?
Yes, sir.
So y over x for 1, 0 will be 0 over 1, which is equal to 0. Is that okay?
0. Yes, sir.
That means the gradient is 0, slope is 0, correct? You know the slope is 0 for a horizontal line, x-axis.
Yeah.
And the equation of line is y equals to 0.
Okay, sir.
Y equals to 0 is your equation of the line. So from the angle, we found the equation of the line also, correct? So both the same, slope and tan theta. That's what I'm trying to emphasize. Correct?
Okay. Yes, sir.
If the angle is 30 degrees, then the coordinate point is square root 3 over 2 x value, and the y value is half. So what is y over x? Y over x is half divided by
By
square root 3 over 2, right?
straight. Yes, sir.
So half 2 cancel. You get 1 over square root 3.
One over square. Yes, sir.
So 1 over square root 3 will be the value. There's a wrong calculation here. Gradient will be 1 over square root 3. Because 2 and 2 cancel, so tan theta is 1 over square root 3. So y will be equals to 1 over square root 3 over
Square
2.
three.
X. Is that okay?
Yes, sir.
That becomes the slope. Slope is 1 over square root 3. Because both gradient and this is the same, because we are taking the other point as the origin itself. Is that okay?
Yes, sir.
For 45 degrees, it's a diagonal line which goes right through the center. Tan of theta will be equal to 1, and therefore slope is 1, and equation line will be y equals to x, correct?
Yes, sir.
In case of 60 degrees, the point will be half and square root 3 over 2. If you find the ratio, you get square root 3, and therefore the slope will be square root 3, and the equation of line will be y equals to square root
Square
3.
3x.
So these
Yes,
are
sir.
all direct variations.
So, sir, only 0 degrees and 90 degrees would just share like the same equation of line, right, sir? Just 0 degrees.
0 degrees and 90 degrees, 90 degrees will be x equals to 0, not y equals to 0.
Yeah.
The vertical line, do you see that? So the
Okay.
y-axis is x equals to 0. So what I've shown you here is that as theta increases, you can see the value of tan theta increases, or the gradient or the slope increases from 0 to 90 degrees, correct?
Yes, sir.
As you can directly see. So there is a direct relation between the lines which you study and tan theta. And the relating thing is slope of the line itself, or the gradient of the line, correct?
Yes, sir.
Now, this is a very important question, which we'll actually discuss almost at the end, where we can take two lines and we can find what is the angle between the two lines. You get the idea now. So it becomes
Yes,
very
sir.
tricky. So if I have two lines, let's say this is one line, and if I draw another line here, right? You know the equation of the lines, correct?
Yes, sir.
And we need to find the angle between the two lines. So from this concept, tan theta is slope, right? You know the slope of both the lines, correct? So that can help you to find this value, the angle between the two lines. So that will become extremely difficult question at this stage, but that's where we can go to from here. You get the idea.
Yes, sir. And then whatever that one angle is, so just reflect on the other side of it too.
Correct. Because you can think, let us say somewhere here is our x-axis. Let us say, right? So you could actually find the slope. You can know this angle and you can know that angle, correct? So this
Yes,
angle is
sir.
what? This angle is phi, right? Vertically opposite angle.
Yeah.
And let's say this angle is theta 1, this angle is theta 2. Then we know theta 1 is equal to theta 2 plus phi, correct? Exterior angle is equal to the sum of remote interior angles. You get the idea?
Yes, sir.
And therefore, angle phi will be equals to difference of the two angles, right? And what are these angles? Angles are tan theta 1 is slope 1, right?
Mm-hmm.
And tan theta 2 is slope m2. So you can find theta 1 and theta 2, correct?
Yes, sir.
And therefore you'll find the other angle also. You get the idea. How do we solve that particular question? Is that clear to you?
Yes, sir.
So I'm leaving that for you. That will be our test question. Let me move forward and take up the other examples which are based on height and distance. But before that, there are two very important terms angle of depression and angle of elevation. So can you tell me what is that? Have you heard about angle of depression?
No, sir.
Okay. So angle of depression is when you're looking from the top, at what angle to the horizontal you're looking at? This angle. You understand? From the top to the
Okay.
horizontal line. So this particular angle between the horizontal line and your line of sight.
Okay, so basically the drop, sir, right? So
Yeah,
at a negative.
this angle, this angle.
Okay.
Let us say you are standing on a mountain and you're watching some lake down below, right? So, and there is a boat there. So, if there is a boat there, in that case, you have an angle of depression. You understand? We call this as an angle of depression. Is that clear?
Alright, sir. Yeah, so
That
like
can solve.
similar as like looking at a bird, it would be the angle of elevation, sir.
Yes, you're right. So, looking at the bird or top of a tree or a building will be angle of elevation. You're right. You'll also notice one thing, that angle of depression and angle of elevation will be equal, right? Because these are parallel lines, correct?
Yes, sir.
So these are alternate angles.
Okay, sir.
And therefore, they will also be equal. So when you make your triangle, you can actually put one angle there, the other angle, and then solve the question. But these are very important things. Height and distance problems can be solved by understanding what angle of elevation is and what angle of depression is. Is that clear to you?
Yes, sir.
So in general, if you look at the situation, here we have a triangle, right? Let us say this angle theta is angle of elevation. You're looking at the top, correct?
But you may be paying
So in that case, what is tan theta equal to?
association for the common
Tan
Height
theta
over
would be height over
distance, correct? So
distance.
from here, you can always find what height is,
that is only that
if
thing,
you know the
right?
distance, and you can find distance if you know the height or the, three things are related, correct?
Yes, sir.
They don't change.
So this is one type of question which we like to do, which is the basic situation.
The fact
Sometimes what happens is, we cannot measure this complete distance. Example for this is, let us say there is a tree and a bird is sitting on the top of the tree. Then you can actually walk up to the tree and measure how far you are, correct?
Yes, sir.
You can actually see the bird angle and then measure this distance. That you could do. But sometimes what happens is there could be a lake in between, correct? So you cannot walk up to the point, correct?
Yes, sir.
So if there is a discontinuity, what you could do is you can walk some distance away, correct? And you
Yeah.
check angle from 2 points. So let's say there's a bird, but there's a stream, water flowing here, correct? So you take an angle from position A, let's say, and then from position B. You know these two angles and you know the distance you covered between these two, correct? So you can find the height. So that is second type of question which we will be discussing.
Okay, sir.
The third type of question is, let's say this is one building, right? Let's say this position is A. From one building, you know the height of this building. You know this height is, let us say, H1. Now you have to find the height of the other building which is on the other side. So what you could do here, you can measure both angle of elevation and angle of depression and actually find what this height is.
Okay, sir.
You get the idea?
Yeah.
There are questions where we could have something like this. Let us say there are two aeroplanes flying, right? They cross one over like this, correct? You
Yes,
can
sir.
find the distance between the two airplanes by finding the angle of elevation and your distance from this particular point. You get the idea?
Yes,
So
sir.
those kinds of questions we can easily solve using trigonometric ratio of tan. And there are many more 3D questions. For example, how do we find height of a mountain? Now you can walk down to the mountain, correct? You're looking at from a very far side, right? Let's say there's a glacier and a big mountain there. By actually taking readings of angle of elevation from two different positions, you can actually find the height of the mountain also.
Oh,
That is how they have done scaling of all the mountains in the world using tan ratio. You get the idea?
yes, sir.
Powerful it is. Now we'll take up some examples to really give you how do we really do it. We just summarize now what is angle of depression, correct? And using angle of depression, we know tan theta is equal to the ratio height over, this is height and distance problem. So you can find height as distance times tan theta, correct? If, let us say this is height and this is distance, and that is the angle theta. Then we can find height if you know it. And we can find the angle if you know height and distance by taking tan inverse of the ratio of height and distance. Let me take an example here. Can you please read example number 1?
The angle of elevation to the top of the tree from 40 meters from its foot is 30 degrees. Find the height of the tree.
Yes. So we need to find the height A, simple as that. We are given that the angle of elevation is 30 degrees. So that is the angle of elevation, right?
Yes,
From
sir.
40 meters from its foot. 40 meters from its foot means this, correct? From its foot, 40 meters. So we know the distance from the foot of the tree. We know the angle of elevation. Tan ratio can help us. So tan theta, theta being 30 degrees, is height over distance. And so what is height? Height is the distance d
Distance.
times tan of 30. So you just
So that
substitute the
will,
values and get the approximate answer of the height. You get the thing, right?
yes, sir.
How simple it is. Correct?
Yeah.
Can you please read second question and answer it?
The angle of elevation of the top of the tree from the eye level of an observer 1.6 meters tall is 50 degrees.
Hmm.
Find the height of the tree if the observer is 60 meters away from the tree.
How is it different from the previous question? Can you tell me that?
The way it's different is because there's two heights, sir. One is the height in which the observer is at from the eye level, and the other one is the tree's height.
Got it.
I mean,
Yes.
yeah.
So now, so that is kind of slight difference, but it makes a lot of difference. So observer is around 1.6 meter, and that is the angle of elevation as shown in the figure is 50 degrees. So, you know, we will have to solve a small triangle on the top, correct? Do you see that? To get the height from the eye level to the top of the tree using the tan ratio, right? And then to
Yes.
that, we will add 1.6 because that is the height of the observer, correct?
Yes, sir.
That is how it is slightly different, and that is how the question is framed. So again, tan theta is h over d. In this case, h is y plus 1.6. Is that okay? And
Yes, sir.
if you look into the smaller triangle, where the y is your height of the smaller triangle, in that case, tan of 50 is y over 60. So y is 71.5 as calculated here. To that, we will have to add the eye level height and get the final answer. So that is how it is slightly tricky, but basically same concept. Is this clear to you?
Yes, sir.
Let's take the next case when we were saying that we cannot walk up to the tree. Can you please read this particular question?
A badger with poor eyesight depends on the honey guide bird to locate beehive, and the bird gets treat to sweet honey as the strong claws of the badger rips apart the beehive.
Mhm.
Normally, the bird points at an elevation angle A, then fly closer to the tree, pointing again at angle beta.
Mhm.
Badger has worked out a formula to calculate the distance and height of the beehive from these observations.
Mhm.
Badger visualizes the situation as shown in the figure and works out the distance using following formula.
Correct.
X equals to d tan A by tan beta minus tan A equals H equals to X tan beta.
Correct. So it's very interesting and it's a very practical situation. It happens in the wildlife normally. So badger, as you know, has a poor eyesight, but the birds have very good eyesight. Now bird locates where is the honey. Bird's problem is that bird cannot rip that beehive and eat the honey, correct? That is the bird's problem. And that's why the bird needs badger's help. You get the idea?
Yes, sir.
Bird knows that this badger can actually climb and rip that beehive, and then we both of us can eat it. That's the whole thing. So, and badger is happy because badger could not have located the beehive without the help of the bird, right? So, bird, what it does, bird sees a badger, and bird knows that that's the beehive at position C, for example. Then bird points at an angle. At that angle, I can see the beehive, one position. Then second time bird hops and then goes to the second point and then again points. That is the angle. Badger notices both the angles and calculates what could be the height using trigonometric formula. You see that? That's the question.
Yes, sir.
So automatically it was, oh, that should be about 3 meters, not bad. So let's go and try it. Correct? So we're trying to see how do we work out this formula, right? Is this formula correct? That's the whole question. So
Okay.
that is the whole question, right? So how you can work out? We can begin with, let's see this. Let's say this angle, we need to find the height h. So tan beta is what?
CD by BD equals H by X.
H by x. So you know h by x from here. Tan alpha is what?
Tan alpha is CD by AD equals to H by D plus X.
D plus x. You see that. So from this, we get this relation. So that's what I've written. Tan beta is h by x. And therefore, from here, we can write what h is. H is cross multiplied, and you can get x times beta, correct?
Yes, sir.
The other angle, again, we wrote h over d over x. Now, from here also, we can find what is h, correct? So from both the equations, we can find the value of h, right? So from this equation, what do we get? We get h is x times tan beta, correct? From equation 1, correct? And from equation 2, we get what? Both h will be equal, right? We get d plus x times tan alpha. Is that clear?
Yes, sir.
Isolated the value of h from both the sides and equated because h equals to h, right? Correct? Is that correct?
Yes, sir.
So we get this particular equation, which is x tan beta equals to d plus x plus tan alpha. Do you get the idea? So we come
Yes,
to
sir.
now it is a question of applying the distributive property, correct? So you multiply tan alpha with d and x, so you get d tan alpha plus x tan alpha equals to x tan beta. We need to find what x is, this distance. First, we'll find that, and then we'll use tan beta to find height, correct? So we are bringing the two terms together to take x common. So we get tan beta minus tan alpha on the right-hand side.
Okay.
So I brought this term to the right-hand side. Is that clear to you?
Yes, sir.
And then you divide d tan alpha by tan beta minus tan alpha to get the value of x. So we got what x is. That is our equation number 4, correct?
Okay, sir.
Now, we know this angle beta, so you can use the smaller triangle, which is height is x times tan beta, right? Height is x times tan beta in this triangle. For example, here, h is what? X times tan beta, correct?
Yes, sir.
So, substituting the value of x, which is all this, times tan beta, we get the formula. You get the idea, which is this formula.
Okay, sir.
Complicated at this stage, however, you understand how Badger worked out the formula, and then knowing the two angles can calculate, right?
So basically, there were two different formulas used to and combined in order to get one formula.
Yes. Does it make sense?
Yes, sir.
So now if you know the formula, you can do a easy, quick calculation. But if you don't know the formula, even then you can work it out, correct? So the idea is you have to equate both the heights, which is solving the two triangles separately. You can also find the distance x and then height, correct? You get the idea?
Yes, sir.
Okay, let's take another example here. And this is the example where I said that from one building, we are trying to find the height of the other building. We can measure angle of elevation and angle of
Depression.
depression from the smaller building. Can you please read example number 4?
From the top of the building, 21 meters tall, the angle of elevation at the top of the taller building is 46 degrees.
Hmm.
The angle of depression of the base, 39 degrees. What is the height of the taller building?
Correct.
So
So
that would
basically,
be,
yeah, we have to find this height. Correct. Correct. How will you do it?
so I would first, since we already got the angle of depression, I would first solve for angle of depression, sir.
Yeah, and we know this height also, correct? Because this is 21, correct?
Yes, sir.
So we'll first start with the triangle ABD. That is important. From where to start, correct? And we know tan of 39 is what? Tan of 39 will be equals to the height, which is, let's call this distance as x, correct? So, or AB, whatever you can say. So it is BD over AB, correct? BD is known to us as 21 and AB is what we can find from here, right? So from here we can say AB is equal to 21 divided by tan of 39 degrees, correct?
Yes, sir.
So that is what I did. So, so we got AB as 21 over tan of 39, which is 25.93. So we got the distance AB, correct? So now we have to solve the top triangle, which is kind of like this. We know this distance now is 25.93. Is that clear?
Yes, sir.
And that angle is 46. And we have to find, let's break this up into two different heights. Let's say CB, right? This is CB.
So we can do tan theta now, sir, because we already have the adjacent side. We just
Correct,
need to
correct.
find for the opposite.
Yes, yes, yes. So let's call this as H1 and then you can find H1, correct?
Yes, sir.
So H1 over 25.93 will be equals to tan of 46. Using calculator, you can calculate what tan of 46 is, and then you can find that upper height as 25.93 times tan of 46, correct? So as I've shown here in the calculations, you can see what we're trying to do. So you can multiply 25.93 with tan of 46, and you'll get 26.85 as this particular height. Correct?
Yes, sir.
If you add that to 21.5, you get your answer. 21.0, you get your answer. Is that correct?
Okay, sir.
This is wrong calculation. 47.85 is the correct answer. Is that clear to you?
Yes, sir.
47.85 meters. Well, you understand now, how can we find height of the other building knowing height of one building? Correct? Very important question from test point of view. Another type of example. Can you please read this?
Anil wants to find the length of the pole AB that is on the roof of a building CB.
Hmm.
The angle of elevation of A and B are 50 degrees and 36 degrees,
Hmm.
respectively from D. The
Hmm.
distance of CD is 50 meters. Find the length of the pole.
Correct. So you can think something like this. There's a flag pole on, right? Flag is hoisted. That type of question could be related with this situation. So how will you solve this? Tell me, how will you solve this?
I would first solve for BC, like
Yes,
distance of BC first,
correct,
and
correct.
then whatever I find out, I can just solve for AB.
Yes. So initially you'll say this is x, correct? And then you'll find the total distance, correct?
Yes, sir.
And then from the total distance, you will subtract smaller distance height, you can say, and then find x. Clear? Easy?
Yes, sir.
Perfect. That's what I did. So I first sorted out for the bigger triangle, tan of 50, the bigger triangle. And I said, well, this A to C is DC times tan of 50, correct? And I found that to be 59.58, capital H. Then I solved the smaller triangles. Order doesn't matter. You could do any one of them. And then you find BC as 36.33. So the distance which we wanted to find is between A to B, which is the difference of the two, and then you get your answer, correct?
Yes, sir. So we just subtracted the two lines,
Correct.
basically.
Correct. Easy.
Yes, sir.
Another type of example could be, this is a 3 dimension, right? You know CN Tower, correct? We're trying to find CN Tower while traveling in downtown Toronto, correct? Now read
Yes,
this
sir.
question. Read this question.
To find the height of the CN Tower in downtown Toronto, Canada, Anil took the advantage of the perpendicular roads. A crossing where the east-west road intersects from the north-south was selected as a point O.
Hmm.
OT was marked as the baseline, 50 meters long, where T is due east of O.
Hmm.
Angle of elevation to the top of the CN Tower from T is 75 degrees. Find the height of the CN Tower if O is 110 meters due to south of the tower.
Correct. Many technical terms are used in this question, and these are generally used for any 3 dimensional figures, right? So let's try to understand these. I've tried to put them all here so that one example will help you to solve any example on 3D situation. That's the whole thing, right? You
Yes,
know,
sir.
we have roads normally they're at right angles. Most of the roads are at right angles, right? They will travel east west or north south. That is how the city is designed. Perfect. So when I say so east west north south, that means at O we have a right angle. Do you see this? This is right angle because the roads which we are talking about are at right angles. Is that clear to you?
Yes, sir.
Okay, because this now it becomes a right angle triangle, and from here you can see. First, let's try to understand the wordings. So I'd like you to understand the wordings, which is okay. Let's read this question once again. I'll highlight the important things to understand. Please read from the beginning.
To find the height of the CN Tower in downtown Toronto, Canada, Anil took the advantage of the perpendicular roads.
Hmm.
A crossing where the east-west roads intersect from the north-south was selected as point O.
So that means at point O, one road is east west and the other one is north south. Do you see that?
Yes,
So,
sir.
so this is going to south, right? This is north south, right? This is going to south and this is going to east, correct?
Yeah,
And therefore the angle in between has to be 90 degrees. You get the idea?
yeah.
It's a 3 dimensional figure. Yes. Now further read.
OT was marked as the baseline 50 meters long, where T is due east of O.
So is due east of O means on the right side as I have shown you, and 50 meters is the distance. Is that correct?
Yes, sir.
So that is a point T. That is a point T, correct? Due means it is on the east side of O, right? So we're talking about this 2 dimension where this is north and that is east. Is that clear to you?
Yes,
So the
sir.
3D figure. On the ground, we are looking at this, north and east. You get the idea. But on 3D isometric view, when we make it like this. Perfect. Now read further.
Angle of elevation to the top of the CN Tower from T is 75 degrees. So CNT is 75.
You understand?
Find the
Hmm.
find the height of the CN Tower if O is 110 meters due south of the tower.
So due south means on the south side, O is 110 meters. You get the diagram now.
Yes, sir. So that's like the distance of where you're from the CN Tower.
Yes. And these are roads, so you can actually measure the distance, correct? You can measure it. But you cannot measure this distance, you have to find. You cannot measure that distance too high, correct?
Yes,
So now we
sir.
can use the tan theta. You have understood the diagram, so I'm erasing all this. How are you going to solve this? Can you tell me your approach, please?
Well, first, sir, I'm gonna since we already have the lengths of 110 meters and 50 meters,
Hmm.
we all just need to find NT. So
Correct.
basically, what I'll do is I'll just add this and then square root it to get my answer.
Yes, using Pythagorean theorem. So we found NT is 120.83 as you can see here, correct?
Yes, sir.
So you got 110 square plus 50 square root to get the answer. Perfect. Once you have NT, now you can see that is a right angle triangle also, right? Because CN tower is standing here, so this is the right angle triangle. So now you can say tan of 75 is what, correct? Height of CN tower over the distance NT, right? So height
Yes,
is
sir.
equals to NT times tan 75.
Which would just be 120.83 tan of 75.
Yes. You can use calculator to calculate this value. So these approximate results gives you a height of CN tower as 450, which is pretty accurate.
So, sir, wouldn't it be 451 meters, sir, if we're looking to the nearest tenth?
Nearest tenth or tens. Find the height of CN tower if 0 is due south. Okay. Oh, yeah. If you are, I'm rounding it to nearest tens. I'm
Oh,
rounding to
okay.
nearest tens. Nearest, this is not tenth, tens. 10, 20, 30, 40. So when you
Yeah.
do tenths, then it is one decimal place. You are correct. Tenth means 0 point something, right? That position. But we are looking at tenths. Correct. Yes. If you are looking into nearest tenth, you will round it like that. But we are rounding to tenths. You get, because
Yes,
this
sir.
is a very approximate calculation. We took an angle of 40, 75 degrees, not very accurately measured. So there is a tolerance. Correct. So the result which we are going to get is also to that tolerance, right? So around 450 meters. That is the height of CN tower. And you can see we can easily solve a 3D question also based on just tan ratio. Did you see that? We didn't
Yes, sir.
even apply any other ratio, sine, cosine, nothing. We just used tan and got these questions right. Isn't that amazing?
Yes, sir.
We can actually solve many questions knowing trigonometric ratios, the secondary ratios, as you know, we know about it. Now, we'll not get into the details of other examples, but you can have a look. Another very interesting example, we will not solve it, but you could take this as your test question. Can you please read the question?
The angle of elevation to the top of the tower is 32 degrees
Hmm.
from a point A due south of it.
Hmm.
The angle of elevation to the top of the tower from another point B due west of the tower is 40 degrees.
Mhm.
Find the height of the tower if the baseline distance AB is 45 meters.
Perfect. So you are seeing we use the term baseline distance. So when the archaeologist is working on this, then what they do is that they do have a baseline to work with. And at the two ends of the baseline, they do the measurements of the angle of elevation. And that is what, the procedure. Is that clear to you?
Yes,
It's
sir.
a very practical example. If you have to find height of a tower, what you could do is you find out on the ground, which is like plain horizontal ground, so which I'm not mentioning in this question, but it's like assumed. So the ground is even horizontal. And then on that ground, you select two good points from where you can see the peak or the top of the tower, correct? And then you know the distance between those 2 points, that becomes your baseline. In this case, the baseline is 45 meters. And then you measure the angle of elevations. Once you know the angle of elevations and the distance, you can actually accurately calculate the height of the tower. Do you see how interesting it is?
Yes, sir.
So that will become your test question to work with, correct? Similarly, we have another very important question here. Now, very important to understand, how do we sketch these 3D figures? This is the most complicated part. And here, the way I have sketched it will actually provide you a solution for most of the 3D questions. Can you please read this question?
Anil and Ben are watching a falcon perched on a nearby branch of the tree. Anil is facing north and has an angle of elevation of 20 degrees to the bird. Ben is facing west. Ben sees the bird at the elevation of 16 degrees. Determine the height of the falcon if the distance between Anil and Ben are 150 meters.
Correct. So as you can see, there's a baseline. Baseline is the distance between Anil and Ben, correct? That is given to you as 150 meters. And the two angle of elevations, 16 and 20. Now we can find the height of the bird. Do you see that? But
Yes, sir.
interesting thing is to understand the diagram itself. So that is the horizontal field. Do you see this particular triangle? This is the base, like your tabletop or the floor. And that is the third dimension, right? We are looking at the height at an angle, right? Angle of elevation. Do you see how to draw this diagram? Correct?
Yes, sir.
That is how you have to draw and then find the result. So that becomes another test question for you. Is that clear to you?
Yes, sir.
So we'll actually end the class here, and I'd like you to summarize today's learnings.
Overall, during today's class, I've learned a lot about how tan is basically used around the world and how it's seen in real life, but also looking at 2D and 3D models and then solving word problem questions based upon it.
Actually, these are all the type of word problem questions which you'll normally get at your level of grade 10. Is it okay? I've gone way beyond that. So I'd like you to again watch this video so that you can pick up these questions and do them on your own. I know the solutions are provided there. However, I'd like you to, just focus on the question, do it on your own. Try to make those 3D figures. That is very difficult. But you have the solution, so it will help you to get the whole idea about it. And then try some questions from your book and also watch other videos which I have on my channel. Okay?
Okay, thank you a
Okay.
lot, sir.
Thanks.
Have
All
a
the
great
best.
day, sir.
You too. Thank you.
Bye.
Bye.